page 16. So turn your packet to page 16.
I'm going to Paul.
Okay. Here's what we were learning today. We're going to talk about phantoms, which is for our hypothesis test. So we're going to learn the whole phantoms process. Page 21, you have phantoms written down the side. Here's what they each stand for. So I'll write all those down, and then I'll tell you more specifically what I'm looking for. Okay, so again, to clarify, a panic is for confidence intervals. Phantoms is for our hypothesis test. So anytime you're asked to carry out a hypothesis test, okay, when I say parameter, I mean choose your symbol and define it. So ours is always either going to be mu or pi. There are different types of hypothesis tests, but these are the two that we're doing. Under H, you need to define the null and the alternative in symbols and words. You still have assumptions to check. The assumptions are similar to the assumptions for panic. There's just one small change. For naming the test, so under N, you need to tell me the number of tails, the test name, the table that you used, and alpha. Under test statistic, this is a formula to calculate Z or T. So basically a Z-score or a T-score. Output or a diagram, that's a normal curve. Making a decision, this is either rejecting or failing to reject. Then under conclusion, you have two different conclusions that you need to make. The first one is you're going to write me a sentence telling me what rejecting, bless you, or failing to reject actually means. Then you need to explain the p-value. Do you remember how with panic, the second sentence, you had to interpret the confidence level, and it was a sentence I just made you memorize? That's what the p-value is also going to be. Sentence that I make you memorize. It's not that bad. I think the best way to see a phantoms is just to do one. Sound good? Okay, now, I don't think I told this class this yesterday, but this is one of the most interesting examples. Hands down, probably the most interesting example that we do all year. So, it's about this woman named Kristen Gilbert, who's a nurse, or she was a nurse. She was a nurse at the VA in Massachusetts. So the VA is a hospital for veterans. To some, she was a lifesaver because she was a nurse. To others, she was a power-hungry egomaniac. I know, you're like, that's a little dramatic, Miss Button. Okay. So, this is the number of deaths by shift from 1988 to 1989. So night, day, and evening shifts. What do you notice?
It's really bad.
Always?
Switches in 1991.
It switches. So it looks like in 1990, the night shift had a lot of deaths. 91 to 95, the evening shift had a lot of deaths, and then it was kind of even all the other years. Right?
She worked there from 1991 to 1995.
So you're like,
During the evening
when did she work?
The evening shift.
This is when she was on duty. There. And then you're like, what about 1990? She was on shift there too.
What?
Okay, this is an actual true story. This woman was tried for murder, and the hypothesis test that we're going to do was presented in court as evidence. So basically what happened is every time she was on shift, there were a lot of deaths. So finally a few nurses said, hey, something's going on here. And she ended up, like I said, being tried for murder. So this is the data for which you guys have for the number of deaths for when she was on shift and when she was not on shift. Okay, so we're gonna start with P. Okay, so the basic idea is we're looking at her death rate. So there's the death rate for the hospital, and then there's the death rate for when Gilbert was on shift. So if we're talking about death rate, what symbol do you think that is?
Average. No.
Rate.
Oh.
Proportion.
Pi. Pi. So we're gonna say let pi be the population proportion of deaths when Gilbert was working. Okay, so under H, we now need to define the null and the alternative. So this is going to be pi equals, that one's going to be pi. Okay, so remember, in a court of law, you are not guilty until proven guilty. So we are going to assume that her death rate is not higher than the overall hospitals. So looking at the data I gave you, how many people died in total? 74. How many total patients were there? 1641. So your null is going to be 74 over 1641. That's the death rate of the hospital. Then we are going to try to prove that her death rate is higher than the hospital's.
Wouldn't we be trying to prove that she didn't? Like, because if we're saying, like, you're innocent until you're proven guilty, shouldn't we try to prove her innocent?
But then we're assuming that she's guilty.
Oh, okay, never mind.
Okay, so this is the null and the alternative in symbols. Now we have to say it in words. So our alternative means that Gilbert's death rate is higher than the overall hospitals. Then what would we say for the null?
It isn't.
It's not higher, yeah. Could we say that it's the same as the hospitals?
Yeah. No.
Yes, because it's, isn't it less
The
than
same
92?
or less than.
Same or less than. So I'm going to say Gilbert's death rate is not higher than the overall hospitals. Okay, assumptions. What do you think the first assumption is if you had guessed?
So we're in a-
SRS.
Random sample. In this case, that would mean that Gilbert was randomly assigned patients.
Do we have to say, like, check assumptions?
Yeah, that would be a good idea. Say something like, we are checking the assumptions. Okay, so like I said, random sample would be that she was randomly assigned patients. Do we know that?
Assume.
I didn't really say, so let's say assume so. Second assumption, large sample. Okay, this is where it changes. How did we check that for panic?
And pi.
And P
Oh my God.
greater than or equal to 10, and 1 minus P, that's how we're going to check it for phantoms though.
With pi.
And pi greater than or equal to 10, and and 1 minus pi greater than or equal to 10. Okay, n is going to come from the sample of Gilbert's patients. So what is n in this case? Bless you.
257.
257. She had 257 patients total. Pi comes from the null, so it's 74 out of 1,641. This is 11 point something. I don't know what, but it's at least 11, so it's greater than or equal to 10. Can't I just stop there?
No.
No, gotta go on. So this is 257 times 1 minus 74 out of 1,641. That's 246 about, which is certainly greater than or equal to 10. So a large sample, I'm going to say yes. See below. Third assumption,
10% rule.
10% rule. So I'm going to say if sampling without replacement, little n has to be less than 10% of big N. A lot of you word this as big sample. No, I'm checking that the sample's small, not big. Okay, little n is 257. What's big N?
1641.
1,641. Okay, you can tell that this is not met. So we are going to say, proceed with caution. Okay, questions?
No.
Okay, now we are on to N. I am conducting. Okay, A. First thing you have to tell me is what the tails are. It's always based off of the alternative. Greater than means that the test is upper tailed. Lower than would be lower tailed. Not equal to is two tailed. So I'm conducting an upper tailed. It's similar, the name is similar to a panic, except it's called a hypothesis test and not a confidence interval. So it's going to be a large sample hypothesis test. For population proportion. Using standard normal table. And alpha equals 0.05. Proportion is always going to use the standard normal table. Alpha is the significance level. So we talked about before with the hypothesis test, what you're going to be doing is you're going to find the probability of getting your sample. And you need to determine if that sample is rare or not. Alpha is the rare cutoff, so it's the 0.05. Alpha is always 0.05 unless I tell you otherwise. Okay, T is where we need to find our test statistic. So it's going to be a z-score. You have to show me the formula, so it's going to be p minus pi all over the square root of pi, 1 minus pi, all over n. So you have to show me the formula, you have to show me the substitution. So we're looking at death rates. P is our sample death rate then, our sample proportion. So this is going to refer to Gilbert. So what is Gilbert's death rate?
40 over 257.
40 over 257. 40 people died out of her 257 patients. Pi comes from the null. So that was the 74 out of 1,641. take out a calculator and calculate the z-score. If I were you, I would save 74 over 1,641 as x. I got a z-score of about 8.54. If you did not, you did something wrong. What does that number mean?
It's 8.54 standard deviations.
Hospitals.
Hospitals.
Yeah. So this number means that Gilbert's death rate was 8.54 standard deviations above the hospitals.
Dang.
Rare or not so rare?
Plausible.
She's innocent. It's not as simple as
Failed to
example. She
retrieve.
could be in the trauma unit, and then she could just have all these people that are like
Failed to
about to die
reject.
anyway. So she couldn't
Well,
help.
then
Keep
it's
that.
not. Then it's not a random sample.
We'll get to that.
If the bullet
It's not
doesn't
large.
fit, she must
What if you're-
What if?
Same
Large.
without replacement.
It was large.
I meant without replacement.
That's checking if the sample is small,
What?
right? Its n is less than, so it's a small sample. Okay, so that's your test statistic.
So we're proceeding with caution, so maybe that could be.
Okay, let's get through the rest of this test, and then I will tell you what actually happened.
I'm not sure.
She's alive. She's alive still.
I have a question.
Okay.
Yes.
If they just assigned her trauma patients, wouldn't that not be a random sample then?
We haven't gotten to that yet, okay? Let's get through the whole test, and then I will tell you what happened in court.
Just curious.
I know, but we need to get through this. So I'm holding it out there for you. Okay, so you need to draw yourself a normal curve. First thing you need is the standard normal labels.
Oh, gee.
Oh no!
You can't fit
Stickers. Stickers.
Alec just turned into a 3-year-old boy.
We score rolled up with the final.
Okay, below that, you need to put the numbers from the problem. So below 0 is our assumed true value, which is going to be pi. Don't write that symbol every time. This is for your notes. Yes,
So why did you go up to 3 on the one side, not on the other side?
because I ran out of room. Because it's a poorly drawn figure.
So
We should do
stickers.
3
would
on the
be
other
better.
side.
Yes, if you have room, yeah. Okay, so our pi is about 0.045. Okay, the way to figure out the standard deviation is everything that's in the denominator. Which I'll tell you is 0.012.
We don't have to show
Wait, what
her
if
for the
it's point
standard
three?
deviation, just draw a line.
No, see, it's like 0.0129.
Oh.
Okay, well I already did 0.012, so just deal with it. Okay, now we need to label her z-value. So I'm just gonna do one of those little squigglies, that means it continues, and then put her over here, 8.54. You also need to put the sample proportion that goes along with that, which is this, her 40 over 257, that is 0.156.
What? Confused.
The 0.156 comes from here, her death rate.
But what are we doing with that 8.5?
That's the z-score that goes along with it.
Oh, so like.
So I want the z-score and the p. Okay, so this means 15% of her patients died when she was on shift, just so you know.
Respect.
That's pretty bad.
Are these people, like,
That is pretty bad,
dying?
yes. Okay, We're almost done. We just have M and S. Right? T-O, yeah, MS. Okay. So in M, you need to calculate your p-value. So we have an upper tail test. So we are calculating the probability that Z is greater than or equal to 8.54. Bless you. So that's the probability of getting her death rate or higher if the null is true. You would do this in normal CDF. You can probably guess what it is.
0.000.
About 0. But do it in the calculator anyway just to make sure that you know how to do it.
I would like a table.
Wait, how do we know it's not the second?
Or how do we do it?
That's what the large sample checks.
Wow.
So remember normal CDF is lower bound, comma, upper bound, comma, 0, comma, 1.
Oh.
Wait, what was that
Second distribution.
again? I see.
I think she's innocent.
6 times 10 to the
That
negative
is
8.
17 0.
Yikes.
17 0.
Okay.
Plugged it in the other way. What?
Lower down is
Wait,
yeah, negative 1. That's pretty
That
bad.
was 8.54. So you're going to do normal
Oh,
CDF.
okay.
8.54, comma,
Negative 18.
1 times 10 to the 99,
That's a wow.
comma, 0, comma, 1. You get it?
Comma, 0, comma, 1. Point, or 6.79
Times
times 10 to the 18.
Yeah, lock her.
Negative 18. Yeah, so about 0.
So
But
18
there's still a small chance.
Going to the same as.
Okay. Oh, first of all, this is called your p-value. That number. Okay, to make your conclusion, or to make your decision, really, you have to compare the p-value to alpha. So our p-value is less than alpha, which means that our statistic is very rare. So what do you think our decision is?
Innocent.
I'm asking reject or fail to reject.
Fail to
Reject.
I mean,
Fail to reject.
Reject, because we got something that was really, really rare. So in the case where your p-value is greater than alpha, that's where you fail to reject.
Lock her up.
Okay, let's just get through the rest of this, okay?
It's not a random sample.
The jury probably is that just like 5
That's
classes?
rarity.
Yeah.
Jury is probably uneducated.
So that is assume that's the normal alpha unless I tell you otherwise.
It's not a random sample.
Okay, we will get to that.
She's innocent.
Yeah, you can't assume.
Okay, here's the conclusion. What?
Can you go back to what you just wrote?
Yes,
Like any way you can.
I can try. Nope, I deleted it, sorry.
It said pay attention.
Kate, do you have it?
No. We were still, we were
It's-
struggling
Joe,
with
do you
the
have it?
CDF thing.
Oh,
What?
Said the kid.
Nah, I don't know.
Like Garrett
It's
said,
Okay.
like p-value something.
I wrote values less than.
if p-value is greater than alpha, you fail to reject.
Yes. Okay.
Probably.
Yeah.
Yeah, it's easier to read your own handwriting.
Okay, this is the conclusion. Write this down.
Oh,
And then we will talk about the whole thing, yes.
Including the yellow.
based on my.
Including everything, yes.
So I
Why
have
is
to
it two
put
different colors?
S in bold.
Why is it
It doesn't flow.
It's a dirty white.
Oh, I thought a lot.
Is this the stuff we have to memorize?
I will show you what you need to memorize. Just write, and then we'll talk.
Isn't it?
The red?
Oh, is it red?
Yeah.
I can't really tell. That's fine.
Are these actual numbers that they used?
Yes, the same test that you just did was presented in court.
How did
Did they have high school students do it?
They did not have high school students presented, no.
Was she innocent? That she is.
If we get through this conclusion, I will tell you the outcome.
She's innocent.
Now they locked
She's
her up.
definitely, you're
in
definitely gonna
asylum.
say like.
But
there
she
was
still
some
lies, so
random-
she didn't
With
fit
the
in.
Yeah,
information
she's
we
not
had,
exempt.
we would say she's not in. But we don't have the same information.
Just
Did
stop,
they-
just stop talking.
did the
Write
glove-
down the conclusion,
Did the
please.
glove
Why
fit?
don't you use the Oxford count?
I don't even know what that means.
Like when you're separating things in lists of 3, instead of putting 2 commas, you just put the 1.
I don't know what
Like
that
if
means.
patients, deaths, and shifts. After deaths, there could also be a
Oh, yeah, the
comma, but you
Oxford
chose,
comma.
it's the
She
Oxford
wasn't
comma.
feeling
I just don't know why you didn't include it.
Because she's part journalist, because journalists don't use the Oxford comma.
Thank you.
Paul, cut it.
It's just kind of,
Yo, like,
Stop.
we know Caitlin's last name.
Oh, no.
Guys, write this conclusion.
Hold on, check that out.
Well, at least.
Oh.
I'm gonna give us a false name.
Okay, we ready to start talking?
absolutely.
No.
Huh, if we were focused, we would be.
No, we
I
should.
focused on
She's
that
still
class.
in it, though.
My hand.
You're right.
You guys better do some hand exercises this weekend then. Because this
Absolutely.
is the rest of the year for us.
Oh, yeah. Didn't realize this was
Most
over.
of the
You just need to remember.
Yeah, I didn't know we were supposed to write in
in
class essays.
See, but if I had warned you about that at the beginning of the year, you would have just dropped the class. So
What up,
I'd like to
bros?
wait till you're.
He dropped it anyway.
Oh yeah, remember when he was in our class?
Wait, he was in her class?
For like 2 seconds.
Yeah, for like 2 days.
No, there's
I
a-
think you scared
Yeah,
everyone.
you hated him. Like, it took you 2
Well, you
days
two
to realize
together
you
was the worst combination of people.
It was awesome.
It would've
I had a
been
great
awesome.
snap.
What
Oh,
is
wait, am I-
VA?
Did I rewrite a
That's
sentence?
the
Oh my
hospital.
God.
Yeah, it's the hospital.
Virginia.
The Veterans Administration.
It's
I
in
ran out of
Virginia
room.
though.
Yeah.
No, it's in Massachusetts.
No, it's in Massachusetts. Okay, now are we ready?
Not even close.
Oh, look, the people who were focused are done.
I
Yeah,
had done
well,
that, and I was
They're making me
focused.
laugh
Yeah,
too hard.
so
You look like you were
Now
done.
I'm done. Fluctuations is weird.
Okay, you have until the pen connects. Oh, it just connected.
Wait
Wow.
a second.
That was really
Well,
cool.
I get the
No.
lessons. Okay.
The difference.
Can we like take a vote on what we think first?
Can we get through this?
I know there's gonna
But
be a
seriously, can we
twist.
just
vote?
There's gonna be
Like-
Stop!
she's a
I just
difference.
want to get through this one question.
Yeah, class
One
one,
question is
class
all
one.
we had to get through today. Yes, if you guys let me get through this without any more talking, yes, we can have a class vote.
Just let me finish it and then we'll be good.
Okay, Ryan, you let us know when you are done.
Alright.
Because there's the glove fit. Connecting to This is the people versus the one.
Okay, I'm done waiting. So I told you, the conclusion has 2 different sentences. This first sentence is the first interpretation. So that is the reject or fail to reject and what it means. We rejected the null, which means we have evidence for the alternative. So I rejected the null, so I believe that Gilbert's death rate is greater than the hospital's. This sentence accounts for the fact that all of the assumptions were not met. So normally you will not have that middle sentence. Normally you're going to have the first sentence and the last one, not the middle one. So the middle one is just saying we're assuming random sample. This last sentence is the one you have to memorize. This interprets the p-value. So this is saying the probability of 0.16, so that's p, the sample proportion, assuming 0.04, that's pi, is too rare to attribute the difference to random chance fluctuations. So what that means is we talked about every sample is going to give you different results. The results of our sample were way too different from the null. So it didn't happen just because of variability. It happened because our initial null was wrong. Does that make sense? Okay, we will practice writing that last sentence because it's going to change a little bit based on reject or fail to reject.
So I'm taking the vote.
We need to get through one more thing.
Just did it.
How could there possibly be?
The last thing I want to talk about is the different tails. And we already talked about this. Greater than is an upper tail test. So you're gonna get some test statistic here and calculate everything above that point. Less than is lower tailed. This refers to the alternative, by the way. So you're probably gonna get some test statistic here and then you go below it. Not equal to. This is two-tailed. Okay, this is the one that's hardest to remember. For a not equal to test, let's say that you get your sample proportion here. You calculate everything below it. Then whatever p-value you get, whatever probability you get, you have to double it for the tail over here. So not equal to is a two-tailed test, so you end up having to double your probability to account for the other tail.
But so you could just add it twice.
That's fine.
So you can see-
Yes.
Any questions about phantoms?
They got a word worse. We think about that.